As you can see here, we have a couple effects going. Obviously we got the water effect, and we got the trees are kind of waving to indicate that there's wind. I'm kind of trying to do this in sort of a old school Sega Genesis style. So that's kind of why I made the trees wave the way they do. And I added a little bit of blur too based on the distance of each layer in the trees. So if you're interested in how this works, I'll just go into it really quickly here. I have this class here called backgroundlayer.cs, and I don't know if this is the best way to do this. It probably would have been better just to manually program everything in a sort of a basic sort of way. But it depends on how many different types of backgrounds you might have in your game and how you want them to work in that. And maybe for each level it works in a completely different way. So these are the different types that I have so far. And then we got a switch down here that draws a bit differently based on what type is being shown. Here we have the X and Y location of the background. X offset and Y offsets just to change the upper left hand corner of where the background is, or the background layer. The velocity X and Y percentages determine how fast those layers scroll compared to the rest of the layers. This is just the width and height, which you actually can get out of the texture, but if you want a custom width and height, you would use these. Just the sprite batch and the type. So when we create the background layer, we're going to load based on the file name that's passed in. We're going to be able to set the X and Y speed percentages. So one would be like 100%, two would be like 200%, it would be way faster. 0.5 would be 50%, so slower. Offsets if you want that layer to be offset for where it's scrolling, and what type of panning effect is going on. So I'll show you in game where we actually create those layers. Okay, so I have this method called load game level, and actually in update it checks a boolean if need to load level, and then it'll load the game level. I'm not actually using load for anything except for stuff that you're going to keep in memory. First of all, I clear the array of backgrounds, because let's see here. Oh yeah, I got a list of type background layer of backgrounds. This stops the music. If we're entering a new level, we want to stop the previous music. I don't even know if this is necessary. I could just start playing the different music selection. So we switch based on what level we're on. You could even have this as scenes or something. So this is adding to the list a new background. And so we pass in the file name, and I've got the files here. Background1, bg layer 2_1. And then we got how fast it scrolls horizontally. For the far background, I don't let it scroll vertically. And then this is just the X and Y offset. For the tree line layer, I'm going to use a Y offset of 400. That pushes them closer to the bottom. I have a skyline layer here. Do I have the skyline in there? I don't think I do. Yeah, I don't think I'm using this layer right now. That's going to be clouds up in the sky. And of course we got to set need to load level to false. Alright, let's go back to the background layers again. This is the scroll method. It's called an update. Takes in the current velocity of the player or the map, depending on how you want to model it. This is the X coordinate and Y coordinate of the background, so we're updating it based on the velocity percentage times the velocity that we passed in, so how fast we're moving. When X is less than 0, then we just add in the screen width so that it repeats onto the other side. We do the same thing with Y, and if it's greater than the screen width, then it goes back to 0 by subtracting the screen width. And we do the same thing for the height. So in the draw method, they might be wondering, well, how does that work unless you have two copies of the background drawn? I'll show you down here. In the draw method, let's see here. Actually, before it draws the background, let's go to the draw method in game. So this is in game. We're setting our current render target. This could actually be done in update, but I'm doing it with the draw. It won't make any difference really, so it doesn't matter. If we are using a far water effect, Okay, but before I get into that, I was going to explain why the background can repeat. Since each background layer in this particular instance is having something quite different done to it, I'm just drawing them one at a time, sort of, with a different setup. So like this is the far one, and adjusting variables for the water. I'll show more about this later. And if we're not drawing a water effect on the far background, this is just the normal way to draw it. You'll notice there's this sampler state linear wrap. You'll see it here too. And what that's doing is when it tries to sample past the end of the texture, it just repeats to the starting of the texture. So if it goes past the right edge of the texture, it starts sampling from the left edge of the texture. If it samples too far to the left side, like into the negatives, it'll start sampling from the right side of the texture. So it's just setting up how the graphics card's going to read the texture as it tries to draw. Background 0 is just the far background. Once this far background has been created and drawn with a water shader in that, we can set the main target and then use that target that we were using before as a texture and then just draw it onto that. Okay, and this is for calculating the waving of the trees. And then this is the tree line here. Right now I just have it drawing the background 1, which is the tree line. And I have a specific case for that in here. So because it's a left-right tree line as the type, it'll draw it differently. Well, it'll draw it like this. I don't have a... Oh yeah, I do have a default. This is just a regular left-right here. So this is how you draw just a single layer normally. Oh, and this REC is just short for this here rectangle. So let's go back down here. I'm setting the destination rectangle, what we're trying to draw it onto, as being 0, y, so the left-hand side of the screen, the height of y, where it's located vertically, and y is set here. Oh yeah, I cast it to an integer, that's why. That comes from the xy coordinate of the background. And then we're going to use the full screen width, and its height will be half the texture's actual height. So kind of squishing it down a bit. And then the source that we're going to get it from is going to be our x coordinate as where it starts sampling from. Like I said, if it samples too far to the right, it'll start sampling from the left side because it's using that wrap method. Starting at x, height of 0, and then here I am saying 2 times the screen width. So this just basically changes the way it interprets the size, and then the texture's height as the source. I'm setting a blur distance, which will be used in the shader, and you can experiment with this value. Like you can see here, I got it 0064, and then for this one, which is a bit, yeah, this one's closer. So that's 004, this one's 0026 because it's closer. 0018, the number gets smaller as it gets closer because it becomes more in focus. And then we got tree waver, which is going to wave the trees. In here in game 1, we actually update tree waver. So if using tree waving, that'll be set up in load level. I think I set that up here, but that should be set in there. So this should be down in here. Actually, a lot of this could be copied into here so that each level has its parameters adjusted appropriately. So the tree waving time. Oh, I should explain this. Tree waving is actually this thing. Struct distort. There's a size, a strength, and a time. Since I find that I use those 3 a lot in a lot of different effects, I just decided to make it its own structure. So I got the water distortion and the tree waving, which can use these. The time loops the waving that's going on, essentially. So this is going to be the angle value that's used with cosine. And once it gets to 360 degrees, it subtracts 360 degrees. And then the waver is set to be cosine based on that angle value. Well, it would normally be an angle value. We're calling it time. It's just some number that ranges between 0 and 6.28. And then we're going to make it smaller, 10%, to reduce the effect of the waving. if you experiment with these numbers, you realize what works and what doesn't, like this timing here and this here. That's kind of how I found all these numbers. Like, I didn't calculate it out, I just experiment. So let's go to the blur effect. Oh wait, I was going to finish explaining this. Okay, so we passed in our wave value, and then we just draw using sprite batch. And I'm giving the furthest one a little bit of transparency so some of that color can bleed through. That's why alpha's at 220, then 229. As it gets closer, I increase the alpha. Just solid, all channels solid for the closest one. And you can vary the hue by modifying your red, green, and blue values here also. Okay, and you'll notice that for the furthest one, I said that the source rect is going to be screen width times 2 because it's the furthest away. And then 1.7 as it gets closer, 1.34 as it gets closer, and then just regular parameters once it's the closest. And then here, for the destination rect, I'm multiplying y by basically 110% here, 126% here, just to kind of offset the destination position of each layer so that each layer is at a different height on the screen. The reason I'm using like a percentage is because I'll actually show you here. The screen recording software is slowing things down. So you'll notice that if I go up, the layers move at different speeds. So it's kind of a 3D effect a bit. If I go way too far down, it'll just loop. You'd have to set up something so that you can't let it scroll any further once it goes past a certain limit. I haven't added that yet, but we'll have to add that later. So you probably understand this stuff, but then how does the effect work? That's this depth blur dot effects. I'm assuming you're a bit familiar with the shaders with monogame, so I'm not going to discuss this part here, but right here we get our texture, and then I have it set to linear wrap. That can actually be bypassed with your sprite batch, but this is the default. And then that's the blur distance and the tree waver that we passed in. It's using the default vertex shader, so we're just going to add this pixel shader to override the regular pixel shader. So this just tells it which method is the pixel shader. This is the pixel shader taking in, and these parameters have to be right. Float 4 position, SV position, float 4 for the color, float 2 for the texture coordinate, and we're returning a color, which is returned down here. Not sure why I have that still. So the ripples themselves kind of have a size to them, and that's what this wave width thing is. And then the ripple frequency is sort of how close together each ripple is going to be. As it says here, 8 times 2 pi, 6.28 is 2 pi, per vertical line of uv.y. So as it goes down the texture, let's see, let's get into the specifics of how that actually works though. So first of all, where we're sampling from, the uv.x coordinate, we're going to add to that sort of a waviness in where it samples from. So we use this cosine of, based on the uv.y, so that each position vertically is going to get its own ripple amount. So that this y value is going to factor the ripple based on how far up and down the tree it is, or how far up and down the texture it is. The tree waver affects the overall rippling of all the trees. So that's added on. So like if I took this out, this changes on a timer. If I took this out and just use this, you'd see ripples in the trees, but they don't move. And this is what makes them move gradually going upward. And this modifies the width of the overall width. It just scales the results so that it ripples differently based on what kind of width you want for your ripples. For the blurring part of it, I initially just take a sample of the texture from the sampling coordinate that we've created. And then I add in samples from the surrounding coordinates. So based on whatever the blur distance is. So maybe it's 2 pixels to the right. In this case, it would be 2 to the right and 2 down, 2 to the left and 2 down, 2 to the right and same height, and then 2 pixels above and 2 pixels to the left. I mean, you can modify this where you have it sampling from just to make the blur look a bit better if that's what you want to do. And because there's 7, see this counts as 2, that's why I multiplied it by 2. Because instead of saying color equals this and then adding it again, I just multiplied it by 2. And then that way 1, 2, 3, 4, 5, 6, 7. There's 7 pixels added together, and then we divide by 7 to get the average color. And that's how you get that blurring effect to happen. Hopefully that's at least somewhat comprehensible. Even if you don't really get it though, like you can modify it and play with it and experiment with it, and eventually you'll probably figure out how it all works. Now, as for the water effect, I made this a while ago and I don't even remember how this works. Let's take a look at it and see what's going on here. So we're sampling from the regular texture coordinate from our background. Oh, and if the y coordinate is beyond a certain vertical position, that seems to be based off of distance plus some cosine value so that it ripples on the surface. I don't remember, was that actually working? Let's take a look. Oh yeah, it's working. You can see it bobbing up and down. Okay, yeah, so when we pass in this time value, which goes into here, that's going to determine the upper part of the water where you're actually going to sample from. So normally you're just sampling your regular color. In this case though, once you reach a certain vertical position on the screen, that's what this says. Once you're down a certain distance on the screen, then we can go ahead and take a look at that. So first we did get a color sample at that point into color 1, and we're going to play with that. Alright, what is going on here? I'm changing the sampling position. Honestly, I don't remember how this works. Right here it looks like we're getting the distance between the pixel and I think the top of the water, and then saying 1 minus that, because like the full distance of the screen is 1, and then we're multiplying it by 2. I don't remember why we're doing that. And then this is all being scaled by the horizontal position minus 0.94 for some reason. And then at the end I put plus 0.94. I'm not sure what that does. You could play with the numbers and see what changes it does. I think it just balances out where everything gets centered. I'm pretty sure that's what that's for. And then that way the moon isn't like skewed to the right or something strange. Like I said, I made this a long time ago. I don't really remember what I was doing. Like a few years ago even. And then, let's see here. Again, this is the distance to the surface, I think. And we're kind of inverting... Or no, wait. First we're scaling it by v-scale. So that has some kind of scaling effect on where it's sampling vertically. And then we're saying distance minus that. I'm not sure how this works. I have no idea how I came up with this crazy nonsense. but it does work. Feel free to use it. And then you could probably use sine for both these or cos for both. Probably doesn't matter. Sine and cos used together usually creates a sort of a circular effect. But the whole point is we want to add some waviness to where it's sampling from. We're taking the current coordinate that we set up here, multiplying it by 15 and adding it to time. Yeah, I'd have to reverse engineer this for a while and think about it. But I'm pretty sure if you play with these values, you can figure out what changes it'll make on the screen and use that to make your own kind of water shaders and kind of tweak them to the way you desire. I think that's how I came up with it. I just kept adding these or multiplying by these different amounts to see what the overall effect would be. So this is changing where the angle is that it's sampling from sine, and seems to be more erratic in the y direction. And then this is the overall scale, how big this waviness is going to be, and then that's added to the current coordinate that we set up. So then we sample from that coordinate and add in the original color and divide by 2. So we average them together, and then we're going to return that color. If we want to colorize this based on the color passed into the draw using this color, we should multiply this color by this color. Okay, hopefully that almost kind of makes sense. I mean, it doesn't even make sense to me. I don't remember how I made this, but feel free to copy that and play with it and see what kind of watery effects you can make. Let's see, let's go back into game 1. Okay, so we got this water distortion time that's being updated each frame, okay, and then it loops it. The time is being used for the waviness, or it's used for animating the waviness. And then the strength is just, let's see here, where are we passing strength? Strength is distance? We're passing in distance with strength? I don't know why. That should be the distance to the water surface, shouldn't it? Not sure why I was using that. And then size of ones, that scales it. We're not changing the size, so. And for this particular effect, there's a vertical, V scale is probably vertical scale, right? Pass in V scale is used here. Okay, yeah. So this is our animation time. Let's see here, how are we using size? Size is passed in here, and do we even use that one? Yeah, we use it to scale the waves. Okay, so we're just going to use a regular scale. We could even take size out of here if we're just going to leave it as 1 for everything. But at least it gives you the option. If you wanted to have it a bit different, like say 1.5, we could try it out. I'm not sure how that's going to look. Oh, that's cool. It's scaling everything horizontally. Okay, I see what that's for. So yeah, just play around with them if you want, and then you can figure out what each one of these is actually going to do. Not a great tutorial for doing water, because I made it a long time ago. I don't really remember how it works, but it is what it is, I guess. But hopefully this will give you some ideas on how you can set up shaders to run in your backgrounds. And here we're just adjusting the velocity of the background, which is passed in when we go background.scroll, and we send in the scroll velocities, and it'll adjust in the background how fast everything moves based on that. Right here, that's the velocity we're moving at, and then based on this particular background speed. And then after we're done, we just draw it all to the screen. Alright, not much else to show you here, I guess. We could play around with how fast the water distorts, like double its speed, maybe increase the strength. And we could play around with the tree waviness too. I could even change that to 0.2 and see what it does. Oh yeah, with 0.2, it waves a little bit further, I think. I think we broke the water shader. Yeah, we broke the water shader. Oh, we could change this one. But we don't want to change this, because that's going to change where the distortion starts. This is actually distance, so let's just add a comment here. I should actually change this, or add a separate variable or something in here as distance, and then use that instead, because that's confusing. Alright. Yeah, that's how I want it to look. Okay, not much else to show, so hopefully that was helpful. Have a nice day.